Okay, so regardless of whether you're confident or you're gonna cram, there's still one goal at the end of when you come into the test. What do you think the goal is when you come into the test?
To pass.
Think positive.
To do your best.
To have fun.
Have
okay,
fun.
that's wrong.
To have
But
fun.
I want you to do your best, and I want you to have fun. But I think your goal should
Like
be.
every soccer coach ever.
I think your goal, when you come in, you shouldn't be surprised. When you come in and you see those questions, you should have done enough questions so that either you've seen that exact same question before, or you've seen some sort of variety with it, so you know how to approach it. Okay. So your goal now is if you're confident, that's great. And here is an example of something you would want to do if you're confident. Basically, it's like a summary sheet. Can you guys see that? It's a summary sheet of a lot of different properties, right? What happens with the first derivative? What's happening with the second derivative? What table values do I need so I can determine primitives or derivatives, right? Those are different things you want to look through in your summary sheet. So all you do is, before you come to the exam, you just read that.
Yeah.
And that's the last thing that you see before you come in. If you're not so confident and you think you need more practice, you need to do as many questions as you can in between now and the exam tomorrow. Okay? You need to cram, you need to see how many questions you can see. So your goal when you come in is that you're not surprised. Here's the other thing you need to do while you're cramming. Okay. Can you see this?
Stay energized.
Can you see this thing?
Lots of coffee.
What's the first heading there? What am I trying to find? You should, for most types of questions, have a sheet like this so that you know what to do when you see a question. Let's do the one that you were just doing. You were doing finding stationary points, right?
Yeah.
What am I trying to find? I'm trying to find stationary points. I'm also trying to actually classify them. That's actually part of the problem. So you need to do that as well. How do I find stationary points? What do I need to use? Someone that was doing
Derivative.
First derivative, yeah. F dash of x is the gradient function. Is there anything else I need to use? What am I classifying? What do I need to use?
Points. So you have to.
Method or the second derivative.
Yeah, you either use the second derivative, which some of you guys did, or that's concavity,
I didn't use either of them.
or you use table method, or then you got it wrong.
I got the right one.
No, but if you don't classify the points, you don't get the full marks. So you need to use one of those. Is there any other important details? In this column, I would put things like, what are the criteria?
Set it to 0.
Yeah, so set f dash of x equals to 0
And then sub it back in.
for stat points. But how do you find the coordinate?
Yeah, you.
What do you have to do? You have to put it into the
Original.
f of x. You should have a sheet like this for your topics so that when you're in your mind, when you're in the test, you're kind of envisioning you're going through these steps yourself. And as you're writing it now, you're confident in doing it. So write it when you're confident. Write it when you're doing the problem, so that when you come back to it later, you're not thinking, oh, inflection, first derivative, second derivative. You're just going to sheet like this, you can follow through the process really easily. Does that seem helpful?
Yeah.
Two other things I would do, if you are confident and you have the time in between now and tomorrow, have a little sheet like this. It's got a sheet of really common mistakes that you've done. Okay, I did a little one myself. For example, forgetting plus c for indefinite integrals. When integrating, what do you have to do? You have to square it, multiply by pi. And this is one I think you guys need to put
Can you
down.
go down a bit?
This one here.
Go down a bit.
Down.
Yeah, let's see what that one says.
So this one says f dash of x is a gradient function. F double dash x is the concavity function. It's not really a technical term, but it's the changing concavity. What's f of x? The original. And this is one you guys might need. What kind of area does the integral give me?
The signed area.
Not just any area under the curve, it gives me the signed area. So if it's below the axis, right, it will be negative. If it's above, it will be positive. Something like this can be really helpful. You look at this and just before your exam, you won't make those mistakes. Okay? You won't make those mistakes. Something really helpful for you. Last thing. Tips and tricks. Again, it's sort of like a fine line between what's a common mistake and what's a tips and tricks, but these are things that can make your life easier when you're looking at a problem. Okay? Sometimes there are better ways to approach things, and you may not be thinking about them immediately, but if you take some time before you actually start a question to think about the best way to approach it, you can save time later on. I'll give you an example. When we looked at classifying points, I could use the second derivative, Or I can also use, what's the other way? The Taylor method. If your second derivative is really easy to find, just use just use the second derivative. But if it's a really big function, like really complicated, like I don't know, x squared plus 5x on 3 plus sine x or something, and you have to find the second derivative of that, you don't really want to do that.
That's easy as.
You just want to use the Taylor method. It's going to be easier. Here's a little trick you might not know. If you're stuck on a maxima and minima question, you can try work backwards. That's sort of a last resort, but let me show you what I mean. Okay, this question here. A timber post with a rectangular cross-sectional area is to be cut out of a log, a diameter of 280 mm as shown. So here's the picture. Show that y equals to the square root of all this. If I'm looking at that and I'm like, where the heck did they get the square root of all this? Keep in mind, how do you get these? You develop these solutions. So they rearranged it so that y was the subject. How could you potentially work backwards from y equals to the square root of this? Yeah, they wouldn't have started with the square root, right? So why don't we square both sides? If I square both sides, I get y squared equals to, remember this whole square root, what would happen to it? It would just go away. And then think about it. When they form an equation, well, they usually have the variables together, right? So if I put all the variables together, I just add x squared to both sides. What does this look like to you?
Circle.
X squared plus y squared equals to this. Pythagoras' theorem, right? And you can see then, by working backwards, they use Pythagoras' theorem to get and form y as a subject for that equation. So that's the last resort. If you can't see what's going on, you can always try work backwards to have a think about what other solutions are. Last thing before you go, and probably the most important tips and trick. So if you haven't been listening, you should be listening now. Can you read that? For curve sketching, only label what's been asked. How big should your drawing be, do you think?
Monstrous.
How much of the page should it take?
Not a lot.
Not much, just as much as it needs to be.
Half a page. I don't care if it's y equals to x x cubed plus 5x minus 3. Your graph should take up half a page. And only label what's been asked. What kind of things can they ask you? They can ask you intercepts. So y-intercepts,
Asymptotes.
x-intercepts,
Stationary points.
stat points. I'm going to say POI for points of inflection, right? They may ask you all of them. They may only ask you 2 of them. They may ask for 1 of them.
So
Right.
draw x squared plus 5x onto minus 3.
I can't do that right.
Ah.
But the thing is, right?
You do what you
Only draw what they've asked you. There is no point trying to find x and y intercepts if they haven't asked them. You're not going to get any marks for them. If they've asked for 3 things, they expect 3 things. If they ask for 2 things, they expect 2 things.
do.
Answer the question. Answer the question. It doesn't matter. It doesn't matter. Only give what they asked for. You can't be penalized for that. Okay. How do you feel about that? So 3 things.
So a question about this question.
Tips and tricks, mistakes, and a little method sheet there. I think I gave you a template for all of those. So that's what I recommend you do tonight.